So, hi again. We have reached the exercise on automata. So, this question was asked in the midterm exam last year. So, we are considering a graph. It's called automata. So, it has the same declaration. So, we have a number of vertices, number of edges, and not an adjacency. It's an adjacency matrix, but it's composed of characters. So we just need to look. So here we have an automated as a direct graph where weights are characters, so weights are not integers. So for that we have a adjacency matrix, but it's of type character, since we need to put the weights as characters. So we need to write a function that reads such a weighted graph, and then we need to write a function that takes a starting vertex, and it's an index, so, and vertex, an ending vertex, and the graph, and also a string. So we need to check if the string can start, if we can loop here, can we find a way, a path that starts from the starting string and ends in the ending vertex. So it's not that difficult, and we have some test cases. So let's start. I'll copy the declaration of this, and let's begin. So we need, since we are using a star pointer, so we need the standard library, and we have the declaration of an automata. So we need to read an automata, so we will return a pointer as we have seen, and let's call it read. So we need an automata, so I will keep it like a graph, and so if you want, you can make a type def here. If it's more difficult, type def automata equal graph. And let's make a malloc size of automata. And then we need the number of vertices and we need the number of edges. So let's say printf, enter the number of vertices, and we do a scanf, so it's an integer, and we have here the address of v, and we have the same for the edges, so enter the number of edges, and here we put e. So we have read both. We need to read those stuff. So first we need to allocate the array of characters, so it's called edge, also capital A, so it's equal char double star, again malloc size of char star, so this is the array, and then we need to allocate, so we need an integer, a counter, let's call it u, and we do a for loop, so u is less than the number of vertex, u plus plus, and we will do an allocation, so here for each element it's a char here, and here a char. Then, so as the graph, we need to fill the adjacency matrix. So here maybe we fill it with a random character. So I picked a star. So we need two counters. So we need two loops. So here we have the first loop. I will use it so that I will not loop a second time. So here inside I will loop over v, and I will place in the adjacency u v, I will put the character star, for example, and then I will return a 0, not 0, the automata. So this is for read, it's very easy, there's nothing in that. Then we need, so let's write the test one and the code from here. So there's not this one, so just to do the test after writing the function recognize. So in test I will read call the function read automata. So we'll have a pointer, and then we need to call the function which is called the recognize. So I will use the same examples in the as it was given in the exam. So let's go back. So we have here multiple example. Let's take this. So if we recognize this, so if it's equal to 1, it should return 1. So I will print that this string is recognized, otherwise it is not. So we need to write the function recognize. So what does it mean, recognize? Okay, so I have here the graph, and let me also copy this one and maybe place it somewhere here. So we have this string. So how can we, if we start from from 0, so we are obliged to start from vertex 0 and end with vertex 3. So if I start from vertex 0 and end vertex 3, can I pass by a pass like that? So let's check. For example, I can pass from 0 to 0, so this is just one A. Then 0 from 0, it's a second A. So let me write it in red. So this is 0 to 0, it's the first A. Then 0 to 0, it's the second A. Then I need to pass B times. So we have 6 times B. So if I go to from 0 to 1, I will stuck because there's no B after this pass here. So this one, it won't work. Again, I cannot take this one, so I need to take the middle one. So I take it once, so this is 1B. Then I need to loop over 2, 1, 2, 3, 4, 5. So I am still here, and then I can take C here. There's no other option, and I reached 3. So it's okay. So I can recognize. So this string can be recognized by this automata. Let us check one that doesn't work. So let's say A, B, 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 B. So let me erase. Maybe I cannot erase. Okay. So we are erasing. So this is the new unrecognized. Now let's check. So if we start from 0, and can we reach 3 if we can find a pass like that? So I'll start from 0 to 0 to 4A, and then in order to have B, a pass with a weight B, so I can take this one or I can take this one. So this one, it won't work, so I need to try it in the in my code. So I need to try this path. So I will pick this one. So this one won't work, so I have this one. So I reach B, so this one B, then I loop 3 times, and then the string finished. However, I didn't reach yet the vertex 3, so there's an so it's an error, so I cannot recognize this string using this graph. So let's move. So they are telling us to use DFS. So we have the function int, it returns an integer, and it's called the recognize. So it takes a graph, an automata. It takes an index for the starting vertex, an index for the ending vertex, and a string. And the function should return 1 if at the end, so if we reach the end of the string and we have reached the ending vertex. So it should be a DFS. Of course, it should be recursive since we are using DFS. So it's said here, please use DFS because it's a hint. So if it's recursive, so in the middle of the code here, so in a while we'll check the stopping condition and stuff, we need to call this function again. So A should remain the same since a pointer to extract. So v, the starting, so as you have seen, the starting index vertex, it's moving while we are traversing the graph. However, the ending vertex is always 3. So here the starting should change. So here I don't know what we will write here, and the end would remain the same. And the string, what happens? Again, as long as we go, we are removing one of the string. So string would be equal to the next element in the string. So obviously it's equal to string plus 1 because I'm moving also with the string. So what I need here is that it's easy now, because if I start from here, what are the possibilities of triple x here? So it's either 1 or it's either 2. It's the adjacent vertices. So I need to loop over that in order to find the adjacent matrix. It's very easy. So I have a for loop and I check if there's an adjacent matrix, and I need to, while going and traversing the graph, I need to check the weights here. So for example, if I have a C here, I will not pass to 3 because I have a C. I cannot match it with the string. So what are the stopping conditions? So as I have said, in order to finish and to return 1, for example, we should have the string, which is, we are moving here the pointer, so look well. So at the end, string of 0 would be equal, or the reference string would be equal to \0. So we have ended, so it means that the string ended, and the start would be equal to end. What does it mean, start equal to end? So end, it never changes, so it's equal to vertex 3. So if I'm moving and I have reached, while I'm calling the recursive call, and I have reached the vertex number 3, it means that I have finished. So start, it's moving, so it's directed, it's going towards the ending vertex, and if we reach that, it means that we have ended and everything was okay. So return 1. Otherwise, it means that I'm in the middle of the graph, so I need to loop over the set of vertices. So I need an integer just for the loop. So here we have 4, v equal to 0, v less than a, arrow vertex, v plus plus. We are just looping over the vertices. So now let's see. We check the adjacency matrix. So if edge of start, so I'm at a vertex and I'm checking the adjacent one vertex that I have, and to check if the string is equal, so if the adjacent is equal to string of 0, or the reference string if you want. So here I check the recognize stuff. So if I can recognize, so here we have v also, I forgot it. So if in the adjacent, if the weight is equal to the string, it means I can choose this path like this one. I need to recognize the rest of the string using from here. So for example, in this case, it will give us 0, it will not give us 1. So if it's recognized, it means that recursively it worked, so I will return 0. If it's not recognized, I will try to choose another path. So this is for the for loop. So let me repeat. At the end, if I tried all the possibilities and it didn't work, it means that I cannot recognize the string. So what I have done here is that I have looped over the adjacent vertices of the starting vertex, and I have checked if I can reach my neighbor with a weight equal to the first element of the string. So I will call recognize on the rest of the string. If it works this, if it means at the beginning we will start from 0, and next we will try starting from 1 or starting from 2. So, while starting from 1, it doesn't work. So here recognize will return 0, and then we will loop over the second possibility, which is 2. Then we will loop over 2. In 2, I need to launch the same recognize function, however again from 2, but with 1b missing, and like that till we reach the C here, and at the end we have a string containing just C. We move with C and then we end with C. So the ending and starting vertex would be equal to each other, and the string ended, so it will work, return 1, and we will backtrack and return 1 to the beginning of the string. So let's write the input and output. So we have here 4 vertex, 0, 1, 2, 3. We have 7 edges, so we have from 0 to 0 equal to A, from 0 to 1 we have B, from 0 to 2 equal B, from 0 to 3 equal to C, from 1 to 3 is C, from 2 to 2 B, and from 2 to 3 equals C. So let's write this here. We have 4, 7, 0, 0 A, 0, 1 B, 0, 2 B, 0, 3 C, 1, 3 C, 2, 2 B, and 2, 3 C. So we have 7 here, 1, 2, 3, 4, 5, 6, 7. So let's execute. Let's see if we have some errors before. So we didn't read the edges. We have just allocated, but we forgot to read the edges here. So we need to read that. So we have placed the allocated array. So we need to read the edges and the weights. So let's loop. So we need another counter because we need to read the vertex. So let's say for enter the edges, we have the number, so please enter, let's make it inside. So for I equal to 0, I less than the number of vertex, and I plus plus, no, it's here edges, and let's say print up, enter the edge and the weight. And we do scanf, 3 values, D, D, and C. We have here address of U, address of V, and we need a character. So let's call it weight char W, and address of C, and then we will place in address UV the character W. So here W, and at the end we will return the graph. Let's run. So we have entered the weight, and yes, the one is recognized. Let's check another one that is not working. So you can make also here to read a string. So it's not recognized. Let us pick also one more function, one more example. So let's say A, why not? So it shouldn't be recognized. And yes, A is not recognized. So let me just skim over the code again. So in the reading automata, it's like reading a graph, weighted graph. However, the trick here is about the recognizing a string. So the stopping condition is where we reach start equal to end, and the string is the ending character, which is \0. As I'm not reaching the stopping condition, I will loop over the adjacent vertex. I'm checking if the weight is equal to the starting string. If it's the case, I will try to recognize the rest of the string with the rest of the graph. So this is for the exercise. This exercise, if you have any questions, do not hesitate to drop me a question or email. I'll try to answer you back as soon as possible. And thanks for watching, and do not forget to subscribe to my channel and to hit the bell icon to receive all the notification. And thanks for watching.